Before the New Horizons spacecraft's 2015 flyby of Pluto, comparatively little was known about this enigmatic little world and its moon Charon. We knew comparatively little about what was in store for the flyby. As a result, Pluto ended up being a surprise, a showstopper with active geology, organics, and possibly even a subsurface ocean, and many other interesting attributes. In short, Pluto ended up being among the most interesting objects in the solar system, well worthy of the title of a planet. And the story didn't end there. From Pluto, New Horizons would go on to show us a trans-Neptunian object in the Kuiper belt, Ultima Thule, which turned out to be a contact binary object, two formerly separate objects touching each other, unusual indeed, and providing much science and insight into these primitive objects that lie in the far outer solar system. And perhaps if another object is found that can be visited, we may yet get more science from New Horizons. My guest today is New Horizons Principal Investigator and was present throughout the entire story of our first mission to Pluto, and now beyond.
Welcome to Event Horizon with John Michael Godlier. In today's episode, John is joined by Dr. Alan Stern. Dr. Stern is a planetary scientist, space program executive, aerospace consultant and author. He leads NASA's New Horizons mission that successfully explored the Pluto system and is now exploring the Kuiper belt. In both 2007 and 2016, Time magazine named him one of the 100 most influential people of the year. In 2007 and 2008, Dr. Stern served as NASA's chief of all space and Earth science programs. Since 2009, he has been an associate vice president and special assistant to the president at the Southwest Research Institute. Dr. Stern's academic research has focused on studies of our solar system's Kuiper belt and Oort cloud, comets, the satellites of the outer planets, and the Pluto system. He has also worked on spacecraft rendezvous theory, terrestrial polar mesospheric clouds, galactic astrophysics, and studies of tenuous satellite atmospheres, including the atmosphere of the Moon. Dr. Stern is a Fellow of the Royal Astronomical Society. He was awarded the 2006 Von Braun Aerospace Achievement Award of the National Space Society and the 2016 Sagan Memorial Award of the American Astronautical Society. In May 2018, his book with co-author David Grinspoon, Chasing New Horizons, was released.
Welcome everyone to Event Horizon with me, John Michael Godlier. If you enjoy what you hear, fall into the Event Horizon, hit the like button, and become an active subscriber by ringing the bell. Alan Stern, welcome to the program.
Well, thanks very much. Glad to be here.
Now, Doctor, your spacecraft, New Horizons, did arguably the coolest thing I've seen in decades, at least since the Neptune encounter of Voyager 2. Now,
we think it's pretty cool.
I remember after the Neptune encounter, it was everybody was like, well, we have one planet left that we haven't yet seen. You know, and these first looks at these planets are not only are they historic, they're also really energizing and amazing. So at the time, everybody's like, well, how do we get to Pluto? How did this start, this New Horizons project?
Well, it wasn't called New Horizons in the beginning. It was really a group of young scientists, myself included, back at the time that you just described, when Voyager finished its job at Neptune and wasn't going to Pluto, who knew that Pluto had a lot to offer scientifically and wanted to see NASA study how to mount a mission there. It's a long and involved trail. It took us 14 years just to find the funding and to get this all started. Went through a lot of ups and downs, but you know how it turned out. It turned out pretty well.
Absolutely, and Pluto turned out. I mean, you know, we didn't know that much about it before New Horizons. We just knew that it orbited distantly, and its atmosphere, would freeze out periodically and things like that. But actually going out there, we find that Pluto is one of the more interesting objects in the solar system. Were you really surprised with Pluto when the mission really got going?
Well, when we started to see the results, I have to say absolutely. We had a pretty good idea. There were some pretty strong hints that Pluto was going to really knock our socks off. But I don't think any of us anticipated really just how scientifically spectacular it turned out to be. It's almost impossible to imagine something when it's just a point of light. And then to see how complicated and beautiful and perplexing the planet is, and its satellites as well, was a joy.
Yeah, now that it pays to mention that in the run-up to New Horizons, we always knew that Pluto had, well, not always, but we knew Pluto had a large natural satellite. But in the run-up, other satellites were found. Were you able to investigate any of those?
Yeah, in fact, all of those satellites that were found by our team using the Hubble Space Telescope, beginning in 2005, and the last one that we found was in 2012. And we looked for them specifically with the intent that if we could determine what was there and where it orbits, that we could plan to point our cameras and other instrumentation to study it. And that worked out great. In fact, we discovered 4 satellites of Pluto, and New Horizons looked at all of them. So we really did the family portrait, not just Pluto and its giant moon, Charon, that had been known for decades, but also the 4 small ones as well.
Now, there were also other surprises with Pluto itself. It had fogs and hazes that were visible, and geologic activity. Could you go into that?
Yeah, the fogs and hazes surprised us a bit. There'd been some talk that some kinds of data before the flyby, things that had been seen by telescope on the Earth, gave indirect evidence there might be hazes, but not like what we found. It really wowed us. We found dozens of concentric haze layers in Pluto's atmosphere that stretch up hundreds of miles into the sky. And to this day, we don't know exactly how the haze forms or how it's so well organized into these dozens of concentric layers. And then, Pluto's geology just blew us away with, tall mountain ranges and ice volcanoes and glaciers and lots of tectonics, evidence of interior ocean. And I could go on and on. Pluto is a little something for everyone there in terms of its activity, right down to the fact that it's geologically active today, and we don't understand how that could even be.
Yeah, especially with it being out frozen, in the outer solar system for a good part of its orbit. Now, given this geology, I remember too that there was basically a big plain of nitrogen that was found, a whole region of just frozen nitrogen, and that was, as I recall, evidence that there may actually be a liquid water ocean that you mentioned underneath the surface of the ice. So this is sort of like an ice shell moon, like Europa or Enceladus. What are the possibilities for maybe life being inside that?
In the ocean.
In the ocean, yeah.
Well, the surface is very inhospitable for any kind of life as we know it. The temperature on the surface of Pluto is 400 degrees below zero Fahrenheit. The atmosphere contains poisonous gases like carbon monoxide, and we just don't see any way that life could exist on Pluto's surface in any form that we would recognize. But deep below the ice, there is a pretty good case for a liquid water ocean. And if that's right, then, we've got the main ingredients for life as we know it. That is liquid water and a warm enough temperature to keep it liquid. And just like Europa, as you pointed out, or Enceladus, or the other ocean worlds of our solar system where we've discovered these vast interior oceans, Pluto is now considered on the list of potentially biologically interesting planets. So that's a complete, pardon the pun, sea change, if you will, from the way we used to think of the planet when we looked at it telescopically, and all we could see was that nitrogen ice on the surface and other ices.
Also evident on Pluto's surface is what looks to be past evidence of liquids on the surface. Would these have been hydrocarbons like Titan or something else?
It's not clear. We have some evidence for liquid water ammonia slurries that may have erupted out of the surface. And we also have evidence for a place that may just be a frozen paleo nitrogen lake. We're going to have to go back with an orbiter with more sophisticated instruments, but also with the time that an orbiter gives you to study every bit of Pluto and its satellite system to understand this. New Horizons was a huge step forward, but it was only a brief flyby. And now we need to go back and really study it the way that we have studied the closer planets.
Now, how has the landscape on that changed? Because New Horizons took a long time to get out to Pluto. As I recall, there was a Jupiter gravity assist and basically almost, pushing the rocket that launched it to its extremes. But things have changed. We now have things like Falcon Heavy, and we have, the huge SpaceX and Blue Origin rockets that are coming. Is this going to give us a faster track to Pluto should we want to send an orbiter out there?
Well, in fact, you're making a really good point. These new launch vehicles are going to help enable an orbiter if it becomes a priority. And NASA just announced in the last couple of weeks that it's investing in a study of how to do an orbiter. But an orbiter's hard, and what makes it hard is that it has to come to a stop. What New Horizons did was fly as fast as we could possibly launch it. It was the fastest spacecraft ever launched in 2006, and it still is. But Pluto's so far away that it took it, as you say, almost a decade to get there, John. So in the case of an orbiter, we can fly fast, but then we have to slow down and stop. And even with the bigger launch vehicles, that's likely to mean the same or even a longer flight time, just because of all the orbital mechanics and the engineering realities of having to bring it to that stop.
And I would assume Pluto doesn't have very much of a gravity well in which to capture an orbiter.
Well, you're exactly right. That's correct. And unlike the giant planets, which can help do the capture because of their gravity, Pluto, which is only the size of, the United States, just doesn't have enough gravity to stop a probe that's coming at super high speed. New Horizons was traveling almost 10 miles a second when it passed Pluto.
It seems to me that the Pluto flyby was special because it really captured the public attention. Everybody was it was Plutomania. And it had everything, even just superficial things like a heart shape on it that just, launched however many internet memes. Given the public support and interest in Pluto, do you think that NASA will, if they decide to do an orbiter, will get prioritized? I mean, lately they're showing interest in the outer solar system. There's that, now approved apparently Titan copter. So maybe, do you see us returning to Pluto within, say, 20 years?
Well, I don't know the answer to that. The way it works in our field is that once every decade, we run a process through the National Academy of Sciences, which is kind of a funny name. It's called a decadal survey. It surveys everything, every good idea that's out there, and then ranks them. It studies them in detail, determines their cost, determines their benefit, and then ranks them. And the top things get funded. But there are always 100 ideas, 100 good ideas for every 5 or 10 that you can afford to do. So the study that I just mentioned that's going to tell us what this mission would cost and what it would look like is a very important input to the next decadal survey, which in fact starts next year and will wrap up with their report about 2 years from now. And if the decadal, which is made up of individuals like myself, planetary scientists, if it ranks a Pluto orbiter near the very, very top, then that mission will happen, almost no question. And if other things get higher rankings, then we won't see that in the next 20 years. And it really just comes down to what the decadal survey decides to do.
Now, interestingly, Pluto seems to be on the mind of Jim Bridenstine lately because he declared that it was indeed a planet, at least in his opinion, just about a week ago, as I recall. Now, people are going to ask me about this because I think most of us out here want Pluto to be a planet. What's your views? Planet or not?
Oh, Pluto, I think I'm in line with almost every planetary scientist there is. Not every last, but most everybody who's an expert, in the field considers the small planets of the solar system just as much planets as the big ones. Of course, the reason we're talking about this is because astronomers who don't know very much about planets any more than I know about black holes in technical detail, their subject, then they famously took a vote, which is something we don't do in science. It's kind of anti-scientific to vote on things. Nobody votes on theory of relativity or continental drift or any other scientific theory. Anyway, to make a long story short, not only does the public consider Pluto a planet, but most planetary scientists do. And Jim Bridenstine, the NASA administrator, the guy running NASA, I think did just the right thing in stating his view, along with us, planetary science community, that these small planets have all the attributes of planets, and people ought to get over the fact that there are just a lot of them. That's the universe that we have. That's just data.
Now, it was the IAU, right, that basically tried to demote Pluto, wasn't it?
Yeah, but they weren't very successful. This was, in my view, let's see, this was in 2006. Now it's about to be 2020. So we're 13 going on 14 years later. And every interview I do, every podcast, every television show, every radio, every print media interview talks about this controversy they created unnecessarily.
Now, this also goes back even further than that. Even when Clyde Tombaugh was still around, there was Brian Marsden was running around saying, it's not a planet, it's not a planet, and seemingly had something against Tombaugh, almost, or at least it seemed that way. What are your views on that? What was his thinking for trying to demote these objects as being planets?
Well, I am told, but I don't have firsthand knowledge, that Tombaugh and Marsden just personally didn't like each other. So you could understand, if that's true, why Marsden might want to undermine the biggest career discovery of Dr. Tombaugh. But I don't really know whether that's true or not. You probably have done more research on it than I have. In science, there's always differences of opinion about things. There's hardly anything in science that's unanimous. And that's what science is really, the way it works, is that we question one another's ideas, and the best ideas win out from the data, and sometimes from computer modeling as well. So leaving aside the fact that there might have been a personal grudge or something going on, Marsden just turned out to be wrong. And, it's very hard to find any scientist that's never been wrong. If we work a lot, then sometimes even the stuff that comes out of the computer doesn't pan out in the long run. Turns out that late in the 1990s and ever since, we've been discovering that the solar system is just littered with small planets, that there are a lot more small planets the size of the United States or continents than big planets. But they're all very far away. Pluto was the first one discovered, but as our telescopes and detector technology got better, we began to be able to see more. And what we didn't know back in the mid-20th century, but did know in the early 21st, is that the deep outer solar system made a lot of small planets. And Pluto's not an oddball that's out there alone on its own. It was the first, the brightest, and the best well-known of this plethora of what we call dwarf planets. And that's not a demeaning term. We call the sun a dwarf star because compared to giant stars, it is very small. But these dwarf planets really turn out to be the most populous class of planet in our solar system, and very likely in the galaxy. Marsden died a decade or more ago, and I think the field has just moved on. I don't think there's a lot of controversy about this anymore.
It could be said, though, that Tombaugh sort of got the last laugh with New Horizons because there was some of his ashes on there, which would, I suppose, mean he would be the first human, deceased of course, but the first human to visit the planet he discovered, and at the same time would be the furthest human from Earth ever to venture out. Isn't that correct?
Both those things are correct. He's also the first human to be launched to the stars, because New Horizons is leaving the solar system. And I was very proud as the leader of New Horizons to be able to do that. It was a wish that Clyde Tombaugh had at the end of his life. He was in his early 90s when he died, and he had said that if a mission ever got launched to Pluto and there's a way that some of his ashes could be put aboard, that was his wish. And when we got close to launching New Horizons and could afford to fly a couple of ounces of his ashes, we reached out to his family and then did the engineering to build a little spacecraft container for it and mount it on the spacecraft and make that dream come true.
It's interesting, the actual discovery of Pluto and how Tombaugh did that with the blink comparator. And you actually cover this in your new book. That, I mean, he must have spent hours and hours and hours just comparing images just to find this thing. Now you can do it much faster, and, Kuiper belt objects, which Pluto apparently is one, are found relatively regularly. And now we know of, as I recall, ones even bigger than Pluto, right? So these would be outer planets, a new class of planet.
So, first of all, we now use computers to do what Tombaugh did by eye, which is to detect moving objects and plot their orbits. And that's a much faster and a much more reliable process. But Clyde was an amazing individual, an amazing ability to concentrate looking at these images of stellar, vast star fields and to find Pluto in it. Today, we use this computer technique and we find asteroids and comets and Kuiper belt objects and small planets and so forth on a routine basis. I do want to correct one thing you said. It's correct that technically Pluto is a Kuiper belt object in that it's an object in the Kuiper belt. Can't deny that. But it's not like most Kuiper belt objects that are the size of counties or smaller. It's really a vast place, and it's large enough to be considered a planet because of the way that it acts. It becomes spherical due to gravity, the geological and atmospheric phenomena on its surface. They all tell us it's a planet. So you could call it a Kuiper belt object if you want, but that's more of a zip code, a location than anything else. I mean, technically, New Horizons is currently a Kuiper belt object because it's an object in the Kuiper belt, just like Pluto. But that doesn't tell you anything about its nature. So, and it's also used to be thought that we had found planets larger than Pluto out in the Kuiper belt, but it turned out that was wrong. To this day, Pluto is the largest of the planets in the Kuiper belt.
Interesting. So that actually got overturned, that it's still the top of the list as far as the small planets of the outer solar system.
That's right. What happened was there was another object, which we call Eris, that some astronomers studying the solar system thought was a little bigger than Pluto. The same way that, the Earth and Venus are almost neck and neck, and turned out the Earth was just a tiny, tiny bit larger than Venus. When we got New Horizons to Pluto and measured its size more accurately, it turned out to be bigger than Eris. So Pluto is, without a doubt, the largest of the planets of the Kuiper belt.
And we have to take a break. I'm joined today by Alan Stern, co-author of Chasing New Horizons Inside the Epic First Mission to Pluto, co-authored with David Grinspoon. We'll be back in a minute for more chat about Pluto and the future of New Horizons.
Be sure to like, subscribe, and share the video. And now, back to John.
And we're back with Dr. Alan Stern. Now, Doctor, Pluto yielded a lot of surprises, but it also yielded mysteries. What mystery of Pluto that sort of arose as study of it advanced? What mystery intrigues you the most?
That's a really tough. That's like Sophie's Choice, It's a conundrum. I would put a group of mysteries at the very top, and not choose between them. So, we do not understand. We are really flustered by the vast scale of geological activity taking place on Pluto, because as a small planet, we would have thought its energy budget would have run out by now, but it hasn't, and we don't understand why. And we really want to know if that ocean is there, and if so, how deep, how far down do we have to go to sample it? And we really want to understand whether Pluto's atmosphere comes and goes and collapses and reforms every Pluto orbit or not. And, those are among the top questions in my book, but I couldn't pick any one of them.
Now, when you were formulating the agenda for New Horizons, you had learned a lot from Voyager, the Voyager program, that you need to make a smaller spacecraft. What was the logic that went into designing what instrument package you would include, and how long did that take?
Those are great questions. When NASA had a competition between teams to see who would get to design and build a mission to Pluto. They didn't just say, send us your ideas. They spelled out what the mission had to achieve in pretty gory detail. So they said, you have to fit in this cost, you have to do it by this date, and you have to accomplish the following list of scientific objectives. And all those things went into the decisions that ultimately resulted in the 7 scientific instruments on board, because we couldn't spend too much and we couldn't dream about technologies that would make us late on the schedule. And we had to accomplish all the scientific objectives: mapping the surface composition, studying the atmosphere. And of course, they're spelled out in real technical detail in what NASA asked for, not just the top level titles like I'm giving you. But there was still a lot of latitude for what types of cameras and how many color filters and what resolution the spectrometers would have and many other things. And so we, as a science team, got together a number of times for days on end, making technical trade studies and debates to settle on the payload that we ultimately did. And then it took about 4 years from the time that we conceived it until it was designed, built, tested, and on the spacecraft ready to launch.
Now, once you did launch during the cruise phase between Earth and Pluto, what went on? What did you guys do with the spacecraft? And as I recall, getting nearer to the actual flyby, there was quite a scare. The spacecraft seemed to seize up. Can you go into that?
Yeah, well, that's a lot. So bear with me. And of course, that's what Chasing New Horizons, the book, is all about, is the story of how we came to win this project and how we designed it and all of the difficulties that we had in making it ready for the launch pad on time and what we did in flight. And, as we flew it across the solar system, one of the ways that we fit in that cost box, which was very constraining, is that we invented a way to do this with a team of only about 50 people. And I know that may sound to some of your listeners like a lot of people, but that's the engineering team, the flight control team, the science team, everybody. And by comparison, when Voyager flew across the solar system to do kind of the same thing, but just for other planets, it's 450 people on that project. We wanted to do it on 50 to get the cost down. Those 50 people had to fly the spacecraft, calibrate all the scientific instruments, navigate, plan the entirety of the flyby. And as the book describes, we actually had to plan 4 different flybys because we didn't know which situation we would end up with when we got there. So we had to have them all ready to test all those plans and then to be trained for any emergencies that might take place. And we had a walloping emergency that took place 10 days before we got there, when the spacecraft quit communicating with us and had a computer reset and lost all of the flyby plans in that computer reset. The book starts off with that story. It's pretty heart-pounding. It would make a great movie. But as you know, and your listeners know, because you've seen pictures of Pluto, our flight control team rescued the spacecraft and did it under the pressure of time because there were only days to go after a 10-year journey. They made it all work out, and we had a flawless flyby.
A flawless flyby. Now, the other thing that struck me in the book about New Horizons is the efficiency of the spacecraft. Apparently the transmitter was way less the data rate of Voyager, and that allowed you to save up data and transmit it back. Have you gotten all the data from the spacecraft from the Pluto flyby?
Yeah, we have. This was a cost-saving measure, and it saved us a lot of money, but at the expense of taking almost 18 months to get all the data back. So we were sending all that Pluto data back from the time of the flyby in mid-2015 until very late in 2016. But that's now 3 years in the past, so all that data has been on the ground a long time.
Has it been studied and gone through yet? Or, could there still be surprises hidden in any data that hasn't been analyzed?
We have looked at all of the data, but the process of analyzing it is a multi-layered process, and I'm sure it will go on for another decade. I like to make the analogy that, when a patient comes into the hospital with a gunshot wound, they're taken to the ER, to the emergency room, where they triage the patient and stabilize them, stop the bleeding, make sure that they're not going to die right on the spot. And then they put them into recovery, which could take weeks. And by the same token, when data comes to the ground from New Horizons, we make the initial analyses of it and then put it aside because more data is coming to the ground the next day or the next week. And we're just triaging those data sets. And then after we get all the data to the ground, we can start to go back and take a second, harder look and do the computer modeling that goes with it. But on New Horizons, our team is also busy flying the spacecraft farther. We did another flyby, not of Pluto, but of a building block of planets like Pluto, something called the Kuiper belt object, just this year. Now all the data from that flyby is still coming to the ground and will be for at least another year. So we're wearing a lot of hats and balancing our time to do all those different things. And so there's a lot more work to be done in all those data sets.
Now, as you briefly mentioned, still on this topic of efficiency, New Horizons was not done after Pluto, as you just briefly mentioned. It went on to look at Ultima Thule, which in itself was a barrel of surprises. Tell us how that came about. What is the process of picking the next object that you can get to with a spacecraft like this?
Well, it's an interesting process. First of all, when we were competing to do this mission, which we talked about earlier, and NASA laid out the objectives that any proposal would have to be able to accomplish. One of them was to go on after Pluto out into the Kuiper belt and to study these little building block objects that are not the size of continents, but the size of counties. And NASA spelled out those objectives in detail. And so we built the spacecraft and the scientific instruments to be able to do that part of the job. And then a few years before we got to Pluto, we started using giant ground-based telescopes to hunt for these little tiny faint embers, these objects that are out there. We couldn't find any. We looked and looked and looked using the world's biggest telescopes and couldn't make it work. And then we started an effort with the Hubble Space Telescope, and Hubble came to the rescue and managed to discover 3 different objects that we could fly to any one of them with our fuel supply. And that set of discoveries was made in mid 2014. And then from the choices that we had on the table, those 3 objects and how much fuel each one took to get to and how long it would take to get to each one and how big each one was, we chose Ultima Thule. And the intercept, the flyby, was on January 1st of this year, just literally 33 minutes into the new year. And it worked out perfectly, not only from a technical standpoint, but Ultima Thule itself has just revolutionized our knowledge of how these building blocks, what we call planetesimals, little bits that come and form before the planets and which together build up into planets, how they were formed. And so it's been very productive. And as I said a few minutes ago, the data is still coming to the ground. There's a lot more to learn.
Now, what's the future? Are there any other objects that have been identified and do you have enough fuel to visit anything further?
Well, we do have a bunch of fuel in the tank still. When the tank's empty, it's empty. There's no filling stations out there, but we've been hoarding the fuel. We have more fuel still on board than we used to do the Ultima Thule flyby. So we're going to look. In fact, we're going to start the search next summer. You might ask why. It turns out that in the direction that we're flying, those constellations against which we're looking for flyby targets are only visible in the nighttime sky in the months between roughly May and August in a way that we can search for targets. So we plan to search in 2020 and 2021. And if we find something that we can get to, we're going to do it. We have to get permission from NASA to fund that flyby. But it's I think a pretty good bet that would happen. I can't speak for NASA, but we sent the spacecraft out there to do this kind of stuff. And even if we can't find another flyby target, there's a lot of really interesting science in the Kuiper belt that this spacecraft and its telescopes and spectrometers can do as an observatory that's not far away back at the Earth, but actually immersed in the Kuiper belt. And we want to wring as much value out of New Horizons as possible, so we plan to do that too.
Now, New Horizons being so far out, solar power is not really an option out there, so you have to use nuclear power, essentially a plutonium pellet. That's going to last a while, so New Horizons is going to be active for some time. When do you expect that the spacecraft will just no longer have enough energy to continue operations out there?
Well, you're spot on. The nuclear battery that's on board is operating perfectly. So is the rest of the spacecraft, for that matter. And we have enough power to run the spacecraft for close to 20 more years. So the spacecraft should be operating in the late 2030s as a stretch goal, maybe even 2040 or so. And so we have a long time to continue using New Horizons to either do more flybys or to study the Kuiper belt other ways.
It's a lot of time to find an object to study.
It is.
Could you viably say it lasts 25 years? In 25 years from now, another object is found. Would it still be viable to actually do a flyby and everything and do all of the same science that was done at Ultima Thule with an object that far out?
There are two things that work against you as you go farther and farther out. One is that the spacecraft nuclear battery produces less power every year. So that means that there are less watts to run things on board. And as we get further and further down the road, we would have to take turns using the different scientific instruments rather than being able to run them all at once. So the flyby would be different for that reason. And then in addition, as we get farther and farther away from the sun, the lighting levels just keep getting lower and lower and lower. And that in turn means the instruments have to strain more to get their pictures and their spectra and everything else. We're pretty confident that we can do a really bang-up job anytime in the next 10 or 15 years. But at the very end of life, when the battery is running out, it would be a lot more challenging. So we're going to try to find something that we can have as a next flyby target in the 2020s. And most likely the spacecraft will be beyond the Kuiper belt by the 2030s anyway. So the chance of getting a flyby then is much lower.
Can you do science that far out? I mean, I know that, for example, Voyager 1 and 2, which also run on these nuclear batteries, are both still sending back data about things like the heliopause. Is New Horizons just heading in the wrong direction to study stuff like that, or is it, just going to forever be until it actually fails within the solar system itself proper? Is it going to leave it or not?
It's a good question. The spacecraft's leaving the solar system and flying out into the galaxy. Whether it's still operating when it leaves or not, no one knows. Even if we have continued good health 20 years from now, when we're at the far range of our power, the edge of the solar system turns out to move back and forth over billions of miles of space. And we don't know where that will be in the late 2030s when we get there. So we can't tell you today whether we'll be outside in the interstellar medium or still inside the sun's cocoon called a heliosphere. We will know a few years in advance, but we just can't predict that far in advance mathematically where that boundary will be 20 years from now.
Now, I have to ask, one of the most striking things from Voyager is when they turned the camera back on Earth. Do you intend to repeat that with New Horizons telescopes?
We would like to do that, and we have the capability to do that. But one difference between us and Voyager is that we don't have any way to shield the cameras from the glare of the sun. And they're very sensitive cameras because they're meant to work so far from the sun out where the sunlight is so faint. It turns out that if we look back to take pictures of the planets like Voyager did, take a solar system portrait, it could burn out one of our cameras because the sun is right there in the same direction. So we don't want to use the cameras to take the solar system portrait until we're past the possibility of any remaining flybys where we would need them. So someday we'll do that, but as long as we've got a chance of getting another flyby, we're waiting to do that.
So on the future agenda, maybe one of the last things the spacecraft does.
Maybe one of the last things we would do with the cameras, but the spacecraft has other kinds of sensors on board that study the heliosphere that we just talked about and do other things. And so we don't need to wait till the end of the mission. We just need to wait until we don't need the cameras for any other purpose.
All right, Doctor, we are out of time. Thanks for joining us today.
John, it was a pleasure.
And today I was joined by Alan Stern, author with David Grinspoon of Chasing New Horizons Inside the Epic First Mission to Pluto. It's a great read. You should check it out. What else awaits us to be discovered in the distant outer solar system? What was once generally seen as the frozen, cold, lonely backwater of the solar system has now shown itself to have no shortage of interesting objects to explore, sparse as though they may be that far out. And it seems likely that there are plenty more to be found. Hundreds or more may still remain unknown, and possibly even entire planets, many of which may be every bit as dynamic and interesting as those of the inner solar system. I can't help but wonder what we'll discover next.
John, you're really happy, aren't you? You found a scientist that agrees with you about Pluto.
Wait, what? Of course Pluto's a planet.
Why not a neutral class of planet? A Plunot.
Plunot? Sounds like a box of candy you'd get at the movie theater. Plunots. Does sound kind of good, though, especially if there are peanuts involved.
There aren't. Raisins, John. Just raisins, no chocolate. You are still on a health week.
Well, you took the life out of that one. And on that note, join us next week for a trip outside the solar system. See you then.